All right, we're off and running. Here we go. 6-3. This is a 1-day lesson. Just 1 day, we're done. We move on to 6-4 on Monday. Okay. So here's what this lesson's all about. It's not a bad lesson to teach on a Friday. Usually Fridays I don't like to teach lessons because it's just you guys have it's the end of the week. It's period 6. It's just tough. But this is not a bad one. Here's what you're doing today. You're gonna find the sum, which means what? You're gonna add. You're gonna find the difference, which means what? Subtract. So what are you gonna add and subtract? Radical expressions. Okay? Just basically square roots, cube roots. You're also gonna multiply radical conjugates. You remember that word at all? We did conjugates back when in imaginary numbers. 2 plus I, the imaginary number I. What's the conjugate? 2 minus I. There you go. So how do you get conjugates? You don't change the first number at all. 2 stays 2. Second number changes what? Opposite. Just give me the opposite. So 3 minus 4i, the conjugate of that is? 3 plus 4. Okay. So this is what you're doing again today. You're going to work with conjugates. And then finally, you're going to rationalize what? And the denominator. And you've done that over and over. So it seems like it's the same thing. And you'll see it. Pretty much is. Okay. Okay, here you go. This is the first page of your notes. So you are going to, in this one, find the sum and the difference of a radical expression. But before I do it, let me just show you something here. 3x plus 7x. You did this in 8th, 9th grade. Answer. 10x. Okay. We had a name for this. That plus that. What do we call it? Like when I say, can you add these terms? You say, yeah, I can add them because
they're like terms.
They're like terms. Thank you. They're like terms. Okay. Well, you're going to do the same thing today, except it's not an x term plus an x term. You're going to get this. 3 square root of 2 plus 7 square root of 2, just like this one. Any guesses? 10 square root of 2? Okay. Yes, you're right. It is 10 square root of 2. What's the term do you think I'm going to call it? I'm not going to say like terms. I'm going to say those are like. Can you add those? Yes, because they're like what? Coefficients. There you go. You said it. No, Molly said it. She said they're like what? Radicals. If you have radicals that are identical, square root of 2 and another square root of 2, well, how many do you have? 3 of them plus 7 more of them make 10 of them. So that's why you can add them. Okay, and here's the thing. It says here to add or subtract radicals, the blank and the blank must be the same. So you look over there. What's the same?
They're both positive.
Oh, they can be negative. Okay, sorry. The index has to be the same. This is the index, right? Square root. Square root. So she's right. It's the index, or we could put what? The roots. Okay.
The number in the radical.
Okay, the number in the radical, but there's a name for that.
I don't know.
Radicand. There you go. The number inside the radical is called the radicand. So if the radicand is the same, and the roots or the index is the same, go ahead and add them. That's how easy it is. So you just take the coefficient 3 plus the coefficient 7, and you get the coefficient 10. Okay? All right, that's really all add and subtract is. This little property right here, guys, I looked at your notes, and it's so blurry, isn't it? Isn't that blurry? Oh, I could hardly read it. Okay, so what I would do if I were you, I'd come over here and just rewrite it. This is what it says. It says if you have a times the nth root of x plus b times the nth root of what? X again. Then the answer will be, hey, you have the nth root, you have the radicand are the same. So you just take the coefficient A plus B. What do those add up to?
And
I don't know. A plus B times what? What's it going to be times?
Nth root of x.
Nth root of x. Yep, that's it. That's what you just did with me. Except now it's more in a mathematical way of saying it. Okay? Take the numbers in front, add them up, A plus B. Keep the roots the same. Keep the radicand the same. That's all it is. All right. And it's the same with subtraction, so I'm not going to write that one down. So let's do it. What's 8 square root of 2 plus how many? 1 square root of 2. Okay, what's the answer? 9 square root of 2. Okay.
B is already simplified.
And it, what's say again?
B is simplified.
Oh, okay, you're already going ahead of me. All right, good with A? All right, jump to B. Why do you say that, Annalise?
Because it has a different index.
Yeah, look at the index. It's 3. It's 2 here. Well, that tells me these are different radicals. I can't add or subtract. They're not like radicals. So I'm going to write the word simplified. Check, it's done. There's a good chance that's on next week's quiz. Okay? You guys have to pick up. You have to show me you know the rules of adding, subtracting, multiplying. Okay? Next, look at this weird looking problem. Are those like radicals?
Yep. Yeah.
Square root. Radicand is what? X, Y, X, Y. Oh yeah, they're the same. So how many square root of x, y's do I have?
7x.
Yeah, it's this coefficient plus this coefficient. 7x times square root of x, y. You just add the coefficients and multiply the coefficient times the radical. Okay? Raise your hand if you don't get it. Say something. John, are you okay?
Yeah.
Okay. Put your heads down. All right. Can you or can you not add these?
Yep.
Same index
Subtract them technically.
and same radicand. Yeah, you're right. You're gonna subtract this time. What's the answer?
2 fourth root of 3.
Fourth root of 3. Good? Okay. Guys, this next problem, I'm going to skip it. I'm going to make you kind of figure it out on your homework, okay? All right? Keep going. Turn the page. Let's go to this page right here. Okay. You are going to add and subtract again. Okay? Kind of curious what you're thinking about A. You see that you're going to add, then you're going to subtract radicals. Do they all have the same indices?
Yeah.
3, 3, 3, cube root, yeah. Do they all have the same radicand?
No.
No. Okay, so we can't do this problem, right?
That's wrong. I'm assuming.
Yes, you can. Why? How?
You just simplify.
It says right here, simplify before you add, subtract. Okay, so how do you simplify the cube root of 250? Well, if you knew the cube root of 250, you just say it, but you don't. So what's a perfect cube that goes into 250?
125.
Yes. So you guys should write that. Okay? Then you should add the cube root of 54. But you don't know it. But you can simplify to what? Look.
7 and
Yeah, guys, it's right here. 27, you can try that. 8, you can try that. What is it?
27.
Times 2, okay. Minus 16, cube root, don't know it. But could change it to what? 8 and 2. Okay. Once I do that, and then I just simplify what I can, you're going to see that you have everything you need. What's this? Cube root 125.
5.
Times the cube root of 2. Plus cube root of this.
3.
Times the cube root of
2.
2. Minus
Two.
2 times the cube root of 2. Whole bunch of cube roots and add, subtract, and the radicans are 2, 2, 2. You're good to go, guys. Who's got the answer?
6 cube root of 2.
6 what?
Cube root of 2.
Cube root of 2. That's it. Add the coefficients, 5 plus 3, subtract 2, you get 6. Keep the cube root of 2 by itself. It just doesn't change. Next problem, it is the same thing. It's a fourth root. So be careful. Get in the right column over there and start working it.
Do you have a different problem?
I have a different problem?
Or no, never mind.
Okay. I'll give you a 30-second head start. You know, some of you are looking at the board, and I'm thinking, why haven't you made this list yet? Some of you should just make that list and have it in your whatever, your binder. Pull it out every day. Okay? I think I'm going to erase this tonight, so I want you to get that on paper. Okay, I don't know the fourth root of 32. I don't know the fourth root of 162. Looking at my chart, what goes into these numbers? What's a perfect fourth power?
16.
Yes, times.
2.
Okay. A perfect fourth power that goes into 162.
81.
81. Okay. Times 2. Okay. What is the fourth root of 16?
2.
2 times the fourth root of 2 plus 3 because the fourth root of 81 times the fourth root of 2. Now you have the same index, the same radicand. You're allowed to add now. Answer?
5. 4. 2.
Fourth root of 2. There it is. Good? Okay, guess what? Addition. It's not totally over, but most of my addition part of this lesson is over. Okay, what are we going to do next? Yeah, now I have to ask you, product means multiply. I need to ask you a rule. What's the rule for multiplication? Tell me. How do I know when I can multiply? You know what I say?
When both numbers are real. Oh.
Same
No.
root.
No. What now?
Same root.
Same root. So she says same root, like this. Nth root, nth root. And what about the radicand inside? They don't have to be the same? So A, B. So what is this times this? Nth root of AB. That's it. That's the rule. So let me just throw one at you. The third root of 5 times the third root of 7. Third root of 35. There you go. That's multiplying. That's how you multiply. Okay? See, this is why we get confused. There's 2 different rules. Okay. It is a binomial times a binomial. What do you think? How do you take a binomial times a binomial? Foil. Go ahead. I shouldn't have to do it for you. Foil this times this and see what you get. First. Outer, inner, last. Okay, I foiled.
Let's see.
Did I do something wrong?
Then wouldn't the square root of 25 be equal
To 5?
to
Yeah, it is. I'm just writing it down. You're right. Okay, so I foiled and I got this. And notice that back here you get square root of 25, but what is square root of 25? 5. So this is really just 5, which if you know that, just put 5 instead of that. What's 5 times 8? 40 with a 6 out in front. So you know the answer is 46, right?
Yep.
Okay, what's this? Those are called like
term.
or radicals, yeah. Terms is okay, but okay, that'd be 16 square root of 5. So you got 3 numbers to add. The only ones you can add are the integers.
So 46 plus 16.
Square root of 5. How come I can't just add the 46 and the 16? They're not what? They're not like radicals. This doesn't even have a radical. You can't touch this with this, okay?
So you can multiply like just a number by something with a radical without the other number having a radical?
Yes, like you're saying this 3 times this, right?
Yeah.
Okay, watch this, Annalise. 3 times 4 times square root of 5. Here's what you have. 3 times 4 times square root of 5. That's what you have when you do that multiplying. And you should know that's just 12.
No, I know. I just didn't know that you can multiply just a number. By
Yeah,
something
this
with
is
a
just a coefficient times a coefficient, and then stick the radical right behind it. Okay? Okay, you ready? Oh, I'm sorry. Are you okay with that? Okay, the next one, it has a little tiny 2 on the outside. What are you going to do?
Square everything. Square everything.
Square. No, don't square everything. That's the problem. Don't do that. You have to take the number inside.
2 square root of 3 plus 3 square root of 5, and then you just put it in parentheses on the other side.
Oh,
Just like double it.
well, I was hoping, I'm sure if I'm understanding you, but I was hoping you just say take the number inside times itself twice, right? Is that what you're saying to me?
Yep.
Okay, so Gavin says take this, 2 square root of 3 plus 3 square root of 5 times itself, 2 square root of 3 plus 3 square root of 5. That's what it means to say square it. It's awesome. So you just, what do you do now?
Foil it.
Foil it. That's it. It's just foil it again. The big trick is write it out. Write it out twice. Foil it. Get an answer. See what you get.
Bless you.
Lightness. Gotta love it.
What?
4 square root of 9. Although if you know that, it's 3. Okay. Okay, I got that. Now, again, when I write the square root of 9, if you want in your mind just to say that's just 3, just put 3 instead. So since you know it's 3, 4 times 3 is 12. You know this is 5. That's 45. What about the inside terms or inside radicals? Are they like radicals? Yeah, what do they add up to?
1 verse 5.
Okay. First integer on the left, last integer on the right, add up to what? 57 plus 12 squared 5. Should I add that and get 69 squared 5?
No.
No. This is unlike radicals. You can't touch those. Okay, you're just done. Good? So really, when you get to this point on the test, quiz, whatever, or homework, that little 2 tells me to write it twice and just foil it out. Okay?
Wait.
Yeah.
Would it be square root of 5?
Yeah, wouldn't it be square root
Isn't it
of
square root
5?
of
Hang on, let me go back. Hang on, where are we at?
So you did 2 square root of 3, just you foiled that out to 3 square root of 5 when you multiply on the radical.
So it's 15, not 5.
Yeah.
So the answer would be 57 plus 12 squared roots of 15.
15. So this is 15?
Yes.
Yes, because, oh yeah. Look, okay, square root of 3 times square root of 5 is 15.
15.
15.
You just add the F.
15, right? That's what you're saying? Okay. I like it. Good job. Okay, this next one, it's like I'm asking you to FOIL again, but there's a reason I want to rewrite this so it's a little bigger for you. I want you to tell me, looking at these two conjugate. Looking at these two binomials, I want you to tell me what they are. They're conjugates. Sorry, I didn't mean to give that away, but I did.
It's already getting away on there.
All right. Oh, yeah, it's right there. Conjugates. Okay. Anyways, you like it when I give it away? You guys, I want you to multiply conjugates and show yourself what happens. Go. Just do it. FOIL it up. Oh, right there. And then what's that? Oh, it's
Oh,
not
this.
Gotcha. Okay. See you on Monday. Okay. Hey guys, look what happened in the middle. 6 squared root of 12 minus 6 squared root of 12. What happened?
0.
Yeah, they cancel out. And just so you know this, when you look at conjugates and you multiply them, they always cancel out, which tells you what should it tell you? When you FOIL, do you really have to do? Where do these come from?
OI.
OI. What's OI?
Outside, inside.
Outside, inside. What I'm trying to say is if they're always going to cancel, do I really have to do outside times outside, inside times inside?
No.
Now, if you don't want to, but some of you don't trust that, and I know why you don't trust it, because you don't realize sometimes when you're doing this. So just do it anyways. You'll see they cancel out. Now, look at this. Square root of 12 times square root of 12, square root of 144. That's just minus what? 12. Okay? 36 minus 12. 24. Okay? So here's the question. What happened when you multiply conjugates?
You get a number.
Yes, you do get a number. And the number is a rational number.
Yeah.
A rational number is just a number that can be written as a fraction. 24 is 24 over 1. So what happened? When you multiply conjugates, the radicals disappeared. So important. You got to know that. So when you go down and do the next problem, it's a division problem. And it's got what on the bottom?
Two radicals.
Okay, say that again. It's got what on the bottom?
Just kidding.
You said it.
Oh,
And
me? 2 radicals.
it's got radicals. So if it's you can't divide by radicals. Now here's the problem. You've never seen this before where you have 2 radicals with addition or subtraction in the middle. So this is a binomial. How do I get rid of radicals on the bottom if I have a binomial?
Multiply it by the reciprocal.
Type it in your calculator.
Multiply by the reciprocal. No.
Conjugate?
What?
Conjugate?
Yes. Didn't I just do it up there? I did the conjugate. Didn't the radicals go away? Guess what? Multiply by the conjugates. Here we go. Skylar?
Yep.
I think it's with Mrs. Kimber. Oh, you already had. I'm sorry. I thought you were coming again. Got it. Thank you.
Not with 5 minutes left.
Thank you. Times what? What's the conjugate at the bottom? Square root of 3 what? Yes. Okay. So now, if you do this, this is where the radicals all disappear. You just have to do it. Okay? Go. Take care of the top, take care of the bottom. See what happens. There's not much to do on the top because the top is just one term times two terms. It's not foiling, it's just distribution. Okay, the bottom you have to foil.
You don't have to do minute terms, do you?
You don't have to do this. I'm just doing it to show you they cancel. Okay. So I foiled the whole thing just to show you that yes, the middle terms do what? Cancel. Gavin just asked me, do I really have to do that? No. I told you. Conjugates, skip the inner, inner, outer, outer if you want. Okay? Anyways, what's 3 minus 5? Figure 2. On the top. Oh, by the way, did the radicals go away?
Yes.
Yeah, that was your number one goal. Get the radicals off the bottom. On top, can you add these two?
No.
No. Why not? The radicals are different. Don't touch them. 2 square root of 21 plus 2 square root of 35 over 2 negative. There's probably one more thing you can do.
Can you simplify cancel both of them?
Yeah, these are fractions. This is a fraction over 2, negative 2. This is a fraction over negative 2. So it's like 2 fractions. What's 2 and 2 going to do? Cancel. So it becomes 1 and 1. This 2 becomes 1. So the final answer is square root of 21 plus square root of 35 over negative 1. Although I don't like my denominator to be negative. So you know what I write instead? I just go like this. Make that 1. But then this would have to be what then? Yeah. And then minus. Okay. And if I put it all over 1, do I really need to write the 1? No. So you guys, you guys could just get rid of the fraction. So this or that works. Okay. Add, subtract, multiply, foiling, rationalize your denominator by multiplying by conjugates. It's all in this lesson. Nothing's really super hard, but there's a lot of stuff here. I asked period 5 this, so I better ask you. When you do your assignment at night, do you have your notes out in front of you?
Yeah.
Awesome. Because you gotta realize what I do with your notes. Your notes are just laid out so beginning, middle, end of your assignment. It's all like in order. Please look at your notes. It helps. Okay? Don't just take them and ignore them. Alrighty. If I could get your homework up there, please.